let's calculate the average atomic mass of oxygen if its abundance in nature is 99.7% oxygen 16. Remember the 16 up at the top here means that that is the mass number. And then we have 0.04% of oxygen 17. So these are isotopes of each other, and 0.2% of oxygen 18 is found in nature. So these are all isotopes of one another. Let's find the average atomic mass. So I'm going to take 16, which is the mass number, right, the mass number, times it by the percent that it's found in nature. 99.76% of oxygen 16 is found in nature, plus 17, mass number of 17, 0.04, right, 0.04 found right there, plus 18, right, plus a times 0.2. Now, we take that, add them all up, divide it by 100, and we round to the second decimal place here, which we end up getting 16.00. For your purposes of putting it into your calculator, as a reminder of order of operations, you need to do the multiplication and addition first, hit enter, then do the division, all right? Or you have to have all of this in parentheses, then divide by 100. But if you just leave divided by 100 off the end, it'll do this first, then it'll do these other calculations. So put that in your calculator and double check what you have and see if you end up getting 16.00 AMUs. If you do not get 16.00 AMUs, then you should stop and ask me how to put this in your calculator. Here's how you can double check that. What you should do is go to your periodic table, find oxygen, it'll be in the second row on the periodic table, and now find the average atomic mass. If you find 16.00 on the periodic table, then you've done something correct, because remember, the average atomic mass is what you find on the periodic table because it's the average of all of the isotopes that are found in nature. That's where we get that number from. Try another one. This time we're going to find chlorine's average atomic mass if it's approximately 8 out of every 10 atoms of chlorine 35 and 2 are chlorine 37. So this time it didn't give us a percentage. Now you could do percentages because we know that 8 out of 10 is 80% and 2 out of 10 is 20%, or you can just simply take the number of atoms that you have over the total number of atoms that you have. So when we put that together, simplifying it instead of making these percentages, right, we've got 35, which is the mass number of chlorine, 35. There's 8 out of every 10 of them, so 8 out of every 10. Chlorine 37 has only 2 out of 10, so this is where I get this 2 from. All right, when I put this in my calculator, I'm going to multiply these together, add and multiply these together, divided by 10, and the average atomic mass, put this in your calculator, that you should get is 35.4 AMUs. Now we can double check this number by looking at chlorine on our periodic table. And since you found chlorine earlier to be the atomic number of 17, you should be able to find that fairly quickly. Take a look at its average atomic mass and see if you have the same number on your calculator, on the board, on the screen, as well as on your periodic table. If you do, then you are correct. Let's try a couple more, and then you can try some for practice before you do the ones in your book.